So your chatbot sounds smart in the demo. It quotes your docs, it answers fast. Then a real user asks a slightly messy question, and suddenly it's confident, wrong, and unhelpful. And the worst part is, you can't tell if it's going to be wrong until after it's actually already damaged the trust. Here is the most common belief. If we just add more documents and connect the search to an LLM, we'll get a helpful assistant. That's the whole promise of a RAG chatbot. But that belief fails for a reason. People don't notice that in a demo. Because real questions are incomplete. Users mix terms, documents contradict each other, and the bot is forced to answer anyway. So you get something that looks articulate but can't reliably help. And that's why these systems fail in production. Not because the model is dumb, but because the system is missing a few basic behaviors human assumes that are already there. The real issue isn't we need more data. The issue is you build the pipeline that produces fluent text, but you didn't build a system that produces useful decisions. Users don't care that the answer sounds good. They care whether it's consistent and grounded in the right source, and whether it admits uncertainty when it should. Here is a simple mental model. 3 layers. If you can reason about these 3, you can diagnose almost every failure mode. Layer 1. Retrieval. This is, did we pull the right pieces of information for this specific question? Not did we find something related. Did we find the thing that actually answers it? Layer 2. Reasoning and assembly. Given what we retrieved, did the bot combine it correctly? Did it follow the constraints, apply the right policy, and avoid mixing incompatible sources? Layer 3. Answer behavior. This is the tone and safety layer. Does it ask a clarifying question when the user's prompt is unclear? Does it cite the right part? Does it refuse when the docs don't cover it? Most teams spend 80% of their time polishing layer 3, writing better prompts, nicer formatting, and they ignore layer 1 and 2. Then they are surprised when it produces a clean looking answer that's wrong. One more key point. The failure you see, like an hallucination, often isn't the model making stuff up out of nowhere. It's the system quietly handing it weak, partial, or contradictory context and still demanding a final answer. Let me give you a realistic story. A team builds an internal support assistant for employees. It's connected to the HR policies, IT docs, and a few PDF guides. In testing, it's great. How do I reset my password? What's the travel policy? Easy. Then someone asks, I'm traveling next week. Can I expense the airport parking and meals if it's a client visit? The system pulls a travel policy snippet about the meals and a separate outdated finance FAQ about parking. The LLM merges them into a single confident answer. It says yes to both, with conditions that sound official. The employee submits the expense, finance rejects it. Now the employee thinks the bot is useless. Finance thinks the bot is risky, and the team hears the model isn't reliable. But when you look closer, it wasn't magic or mystery. Query needed a clarifying question. Which office, which region, which policy version applies? The system also needed to prefer the newest authoritative dog and flag conflicts. And it needed to say, I'm not sure. Here is what I found, and here is what's missing. That's not a model problem. That's the system design problem. Here is a quick checklist of common mistakes I see over and over. 1. Treating search results like truth. The top few chunks can be relevant but still not answer the question. 2. Ignoring contradictions. If 2 documents disagree, the bot shouldn't average them into a smooth answer. 3. No clear fallback behavior. If evidence is weak, it still answers like it's certain. 4. Optimizing for demo success and not evaluation under messy real user prompts. 5. Shipping without monitoring, so you don't notice drift, new docs, new policies, new terminology until complaints pile up. So what do you do instead? Here are the practical steps you can apply even before you touch tooling. Step 1. Write down what helpful means in your domain, not abstract, specific outcomes. For examples, user can complete task X without escalation, or answer includes the policy section and date, or if uncertain, Ask one clarifying question. Define success like a product, not a model. Step 2. Design the question flow. Decide when the system should answer, when it should ask, and when it should refuse. This is where you protect the trust. A great assistant doesn't answer every question, it manages uncertainty. Step 3. Make your knowledge base behave like a single source of truth. That means identify authoritative docs, handle versions, and decide what happens when sources conflict. If you don't resolve that upstream, the bot will resolve it downstream by guessing. Step 4. Test the system the way users will break it. Collect messy prompts, partial context, slang, what-if questions, multi-intent questions. Then check 3 things separately. Was the right info retrieved? Was it assembled correctly? And did the response behavior match your rules? Step 5. Decide what will you watch after launch. You don't need fancy dashboards to start. You need a weekly ritual, sample conversations, label failures, and ask, was it retrieval, reasoning, or behavior? Then fix the right layer. In the next video, I'm going to show you a simple way to separate the bot answered wrong into 4 specific categories. So you can fix the problems without guessing and improve reliability without endless rewriting prompts. If you're building this in production, design for consistency first, and the smart will follow.